Now today we have discussed what is the functions which are convex on an interval and concave on an interval, right? And that f be a real valued function on an interval I which is contained in R. F is said to be convex if f of this line segment, this is the equation of line segment, if the function's value on the line segment is always less than equals to t f of a plus 1 minus t f of b, then this function is said to be convex. That is the means this is the chord between the graph of this point and this point lies above the graph, then the function is said to be convex. What's the function is said to be concave? If function is said to be concave if the line segment's function on the line segment which is greater than equals to t of f of a plus 1 minus t f of b for all t is in closed interval 0, 1 and all a, b is in I. That the mean is the chord between the graph point A and the graph point B lies below the graph of f, right? Now how to it is from the theorem, this definition is from taken from the graph. Now how do we convert it in the real analysis? In the real analysis, when we know that the function is concave and convex, finding out by the second derivative of this. If the second derivative of the function is positive, then the function is convex. If second derivative of the function which is less than equals to 0, then the function is concave. Now what is the example of that? Let us take the sine of alpha plus sine of beta plus sine of gamma which is less than equals to 3 root 3. As we know that sin x is concave on 0, pi, its second derivative is minus sin x which is less than equals to 0. So it is concave, and if it is concave, then the value of this sine of alpha plus sine of beta plus sine of gamma upon 3 which is less than equals to, this is less than equals to sine of alpha plus beta plus gamma upon 3. What is the value of this? The sum of the triangles, angle of the triangle is pi, then it is pi by 3. So this gives root 3 by 2 and it is less than equals to root 3 by 2.